So now I'm going to walk you through how to collect the information for this activity, this experiment. First, read the instructions clearly. So key question is, how does the way energy is stored in the system change as the skater moves through the half pipe? What happens to the total energy of the system? All right, so that's what you're looking for. The first thing you're going to do is you're going to open the simulation. So I've got that here. I will open that. And it says to check all the boxes in the right on the right of the simulation. Click on the skateboarder, place him on the track, let him go. Click the slow motion at the bottom if you need to make things easier to follow, and then note your observations below. So let's go there. First thing we do is, let's see if I can make this a little bit bigger. Let's see. So we're going to click all these boxes. So this is a pie chart. It's going to basically have a pie shaped like that. It's going to have kinetic, potential, and thermal energy in it, and they're going to be changing. The bar graph is going to be the same information depicted in a bar graph. Grid is going to help us measure where things are at any given point, and then the speed, which we probably won't need for this part of it, but we will down the road. So those are all checked. Move what I'm looking at here. Take the skateboarder and put him up on the half pipe, and I'm going to let him go. So because there is no friction in this experiment, you see what's going on. You see the energy is going back and forth between kinetic energy and potential energy. Is the total amount of energy in the system, which is the sum of these at any point in time, is that changing? No, it's not. And let's see if we can get the pie chart visible someplace. Oh, it's over there, dude. Okay, it's going back and forth, essentially the same as this. And there's no energy being lost, so it's just going back and forth between kinetic and potential energy. Let's see if we can figure out how to answer those questions. So slow motion will give us a little bit more time. So we're going to slow him down. So he's going faster and faster and faster. It seems to be going the fastest when he's at the bottom. Is that correct? I can pause it. Let's see. Okay, I'm going to step forward frame by frame. You see the little sliver is going away. When he's at the very bottom, it's all green, so that means it's all kinetic energy. The speed is up here, and let's turn him on again. And let's see, when we go step forward, boom, 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 boom. Speed is going down to 0. Now he's at the very top again. So he's at 6 meters, falls 6 meters, goes back up to 6 meters, back down to 6 meters. All right, so let's go back to the questions and see if we can answer them. So let's review the question. How does the way energy is stored in the system change as the skater moves through the half pipe? Well, what do we know? When the skater is at the top of the half pipe, he's got all the potential energy and none of the kinetic energy, right? And as he falls down, gets to the bottom, then all of his energy is in the form of kinetic energy, and none of it is in potential energy because he can't fall any further. And then he starts climbing back up and gets back up to the same point he was at before. So what does that tell us? It tells us that all the energy is either kinetic or potential, and it goes back and forth between those two. If we looked at the bar graph, if you recall, the bar graph, the total energy does not change. It just switches back and forth between the two, but the sum total is the same, right? So what are the observations you might make here? You might say the amount of potential energy depends on his height above the bottom. You might say that the amount of kinetic energy depends upon the how fast he's going, his speed as measured. So I'm going to leave those observations to you, but that's essentially how you would go through and get the information from this this example, and you put your observations there. Remember, your observations are supposed to be what you observe. You don't have to explain anything here. This is just what you have observed. All right. So be careful that you are just getting the information and you're not interpreting it.